Okay, for today, this is Friday the 15th, and we are just taking a top 20 in class today. So if you missed today, the main thing you're missing is a little bit of review for the top 20, and we're going to take it in class. So if anybody's absent today, I'll just give it to you in class when you get back. The one on the board here is one of the classic top 20s, and it has a lot to do with factoring. I've already factored the top. Can anybody in here tell me what the bottom factors to? Is there seriously nobody knows how to do this, or you just don't want to answer? All right. Good, because the bottom can't be factored. All right. Now, that's an important thing to know. Like, some people think that everything can be factored. That one can't be. All right. Good. Now, what could you do to solve it if you couldn't factor it? This can still be solved if I set it equal to 0 and use the quadratic what? Formula. Okay. So you don't have to be able to factor it. But, all right, you passed the cheat fake question. Now, can you factor the real one? That one actually will factor. Can you factor it? At a minimum, most people know that you can start with an x and an x. I hope you can get that far, okay? Given that you're signed up for the honors class, I bet you can do that. Then, these two numbers that are here and here, those two numbers need to multiply to 5. And there's not many things that do. I purposely chose these numbers so that they're easy. Because like if I put a 24 right here, you'd have like 8 million possible things that multiply to 24. But a 5, there's only one way to get 5. What do? 1 and 5. 1 times 5 makes 5. Now, some people say, what about 2 and 3, Mr. Server? Well, 2 plus 3 makes 5. It's times. 1 times 5 is the only combo for 1 and 5. And now, since there's only pluses in here, then there can be only pluses in here, and then I'm done. And how do I know I did it right? Because if I multiply out the FOIL of it, first, x squared. Outside 5x, inside 1x, makes a total of 6x. And the last, 1 times 5 is 5. Now, some people use FOIL, and some people just do it this way. You take this one and times it by both things, and you take that one and times it by both things. That works. It still gets you the same thing. You don't have to do first, outside, inside, last. You just have to, all 4 parts have to get multiplied. And then when you do, it comes out to this. That's how you know you factored it right. Okay, and now, factoring is huge. It's so big that I will make a bold statement. If you don't know how to factor and you keep it that way, if you just like never learn to factor this year, you can't get an A in here. There's no way you could get a high enough score on everything else to make up for that. So you need to learn this now. Okay, so factoring's your weak spot. Got to start practicing now. And I got a video for it. And if that's the thing that's you're weak on, what I suggested is that you write on the little post-it-y thing there any skill numbers that you are not good at. And then you just go to my website and you find where it says videos. There's only like 4 tabs across the top. Find the one that says videos. And in there, there's a list of all the videos. I mean, 270 videos. That's a lot. And I posted them all for kids like you, so that if you're stuck on something, you can get my help on how to fix it. Okay, so use it. If I took all the time to make it, you should take at least, literally, they're like 2 minutes long. That's my little tagline, 2-minute teacher. Okay, because I can teach you anything in 2 minutes. Now, you can't give people all the background and help them really understand it, but you can get right to the point. That's what I do in these videos. They're quick. All right, so now that I got it factored, that cancels that because it's a multiply problem, and when you're in a multiply problem, you can cancel stuff. So the x plus 5 and the x plus 5 are gone, and what's left is x minus 5 over x plus 1. So I wanted to talk about that one today because I'd say it's the most important one because it involves two kinds of factoring, and factoring is one of the most important things of the whole year. But now we're not even going to teach you much because we kind of expect you already know it. But I know that a lot of you don't know, and that's why I'm taking the time to do this, so that you can bolster up those skills, which are also big for the ACT, and be so much better off this year. All right, here's the next one I want to talk about, and it's, again, something that I can explain pretty quick. If I had this problem, would you please write it down? And if a kid knows how to do it, you can do the answer in literally 10 seconds. I could tell you that answer in probably less than 10 seconds. Okay? But if you don't know how to do it, that doesn't help to say it can go really fast. If you don't know what to do, I should probably show you a way that would always work. Do you remember me saying that if you can factor it, factor it? So 25 can factor, but I'm going to look at that number and choose wisely because I don't want to use 25 times 1. That'd be kind of dumb. I should probably use a 5 because there's a 5 on the bottom. See? So I'm going to factor the 25 into 5 times 5. Next, I'm going to factor the x squared. What is x squared made up of? X times x. Do I need to keep putting dots all the way through? No. This is supposed to go fast, or faster anyway. So y to the third is y. That's what it means. All over 5x, and then the y to the fifth. That's a little bit of a pain, but it doesn't take that long to write 5 y's. Now guess what's going to happen? Stuff's going to cancel. And so one misconception some people have is that like all the 5's can cancel. No. 1 5 from the top, 1 5 from the bottom. And when you cancel stuff, you're technically leaving behind a 1. But do I need to write those ones? No, that's going to waste time. Then an x and an x cancel. And there's another x on top. Can I? No, I can't cancel that because there's nothing to cancel it with. And lastly is the y's. Y. And then you can just read what you have left. What do I have left on top? 5x. What do I have left on the bottom? Y squared. That's the answer. That's all there is to it. So those kind are not that hard. Let's do another one like that. 35x squared y over 15x to the third y to the 0. I'll just add a little twist there. See if you can handle that one. Make it into its factors, cancel stuff, unless you're awesome at this in the first place. If you're awesome at this in the first place, just write the answer. I'm fine with that. If I could pick a skill for you, I think it'd be better for you to know how to multiply than to know how to add in this class. I know I'm saying it sounds dumb, but multiplication happens so often. And you have to get factors so often that you end up multiplying and dividing more than you add and subtract. It's kind of a dumb choice. It's like, would you rather be able to breathe, or would you rather, be able to, what else do we need? Drink water. Okay, well, if you get if either one of them gets cut off, you die. In math, if you can't add, yeah, you're kind of toast too. But multiply happens more than adding in this class. I really think it's true. All right, so this is 7 times 5, and that's xx, and then there's just a y, so I put a y. And this is 5 times 3. Now, could you have multiplied this 15 as 1? Yeah, but that'd be dumb because I got a 5 on the top. And this is xxx, and then y to the 0 is technically equal to 1. In case you didn't know that, it's good to know. And times by 1 doesn't really do anything. I don't even need to put it there, but can if I want. And then it cancels, and did you have y, oh wait, the 7y over 3x. Raise your hand if you had that. You got it right then. You got another one of your top 20 down. The one that a lot of people got wrong. I looked. All right, so there's a couple. Now I'm going to check my time. I'm going to pause a second while I check the time. I'm going to do another one with you because I got about 6-7 minutes left. So I now will take a nomination from you. I will not do the problem off the test, but you may look at your test. Nobody can start the test, but you can look at the test you're about to take a second from now. Are there any on there that look kind of simple, but you are afraid you might get wrong, and we can talk about that kind? Yes, sir? Okay, would you read me number 10? And I won't do that, but I'll do one like it. I can see it now. I'm going to save you some time to not have to read that all to me. All right, everybody flip it back over. That is a classic that a lot of people get wrong. Let's talk about this. Let's say it was this. It's not, but, you know, yours will be similar. Order of operations comes into play. Parentheses are supposed to be first. But there's nothing I can do in there. So then you move on. Okay. And go move on to the power. 3 to the third, a squared to the third, and b to the third. This time, there's no plus in here. So yeah, you just do all of them to the third. But 3 to the third, most people know is 3 times 3 times 3 is 27. That's not that bad. But a squared to the third, people get confused on whether you should times the exponents or add the exponents. But let's talk about what it means. What does a squared to the third really mean? It means a squared times a squared times a squared. That's what a to the third really means. Now can you tell whether the answer should be a to the fifth or a to the sixth? To me, writing this out makes it really obvious that a squared to the third is this, then it's really a to the sixth. Does that make sense to you? And I could just say, memorize it. You got to multiply the exponents. But you're going to forget whether it's multiply or add them. And you can write it out like this because that's what cubed means. And then it should be obvious that it's to the sixth. And then it's b to the third. Technically, that was a b to the 1 times 3. 1 times 3 is 3. And then I still have a 2ab to the fourth to deal with. Notice, there has never been a plus in this whole thing. It's all a big multiply. So now, what two things can go together? Can I, like, multiply a's and b's? No. Well, I could multiply 27 and 2, and that would make 54. And I could put the a's together. There's no exponent on this. Does that mean it's a to the 0? No, it's a to the 1. And that goes together and makes a to the 7th. All right, and if you want to know what does it really mean? 6 of them, 1 of them, put them together, 7 of them. All right, and then you got b to the third, and b to the fourth makes b to the 7th. There you go. Any questions on that one? Okay, I'm getting down there. I got time for one more. Flip the thing over, and I'm going to see if more than one kid asks. So I'll just have you say your problem number, and if like there was like 4 hands. I know I can't call on all 4 of you, but so you can raise your hands again. If you all ask for the same one, or like 3 people want the same one, I'll pick that. Okay, Ellie. 11. Everybody look at 11. Would anybody else have raised their hand on 11? All right, a bunch of people. Let's do 11. Ellie, read it to me. I won't do that one, but I'll do one like it. Ah, I know that kind. Okay, I'm going to do this. Everybody write this one down. It's not number 11, but it's like it. So go back to the back side. 5 plus and minus the square root of 50 all over 15. So how do you start this kind? Well, first of all, that square root has to get fixed. So, Mr. MK, can you tell me how to fix that square root?
Well, you take the square root of 3 plus square root of 25.
Exactly. Why did you pick 2 and 25? Because you could use 5 and 10. Why was 2 and 25 smarter? Yeah, because if he had chosen root 5 and root 10, neither one of them worked nicely. But of the green ones he did, which one of them does work nicely? Square root of 25, so then you know the answer is 5 root 2. How many of you think you can do that part of it? All right, if that's something that's not in your wheelhouse yet, there's a video for that. Go watch the video for it. All right, this, and this, and this all have a 5 in them, don't they? But here's the thing that people are tempted to do. They're tempted to go like this. Well, I see this 5 and this 15. I'll just cancel this and make this a 3. Nope. You got it wrong. Why? Because that 5 right there is part of an add problem. You cannot cancel that 5. But we can factor it. Remember me saying if you can factor it, factor it? That can be factored. Then when you pull the 5 out, it'll be part of a multiply problem. Then you will be able to cancel it. Okay, so the bottom's 15. Don't touch it. The top's got 5 in both parts. Next common misconception. People pull out the 5 and they think there's no 5 left, that it's gone. And you got plus and minus, and they know to take the 5 off the root 2, and they have a root 2 here. What's wrong with that? You can't factor like that. There should be a 1 left over. Why? Because if I multiply this back out again, 5 times 1 is supposed to give me 5. If I don't have a 1 there, do you get that when I multiply this back out, it'd be 5 times nothing? It'd be like there was no 5 there. All right, so you have to have a 1 left over. You've heard of a placeholder before, right? That's kind of holding that place. When that 5 cancels, it leaves behind a 1. Okay, so there, I factored out the top, and the bottom is a 15. But it'd be smart, if you can factor it, you should factor it. So I factor the 15 into what times what? 5 times 3. And now my 5s can cancel. Doink, doink. And there's my answer. And people oftentimes are like, that's the answer? Yeah, because I don't know what the square root of 2 is. Have you memorized the square root of 2? I haven't. So then I can't do it. Now, if it had been square root of like 16, then I could actually do it. I'd go 1 plus that answer divided by 3, and 1 minus that answer divided by 3. But I don't know what square root of 2 is, so I have to leave it as 1 plus and minus root 2 all over 3. All right, to summarize what I did, I started this problem by fixing that square root, and most of you said you could do that. Then I noticed that they both had a 5 in them. On my top 20s, they will always have something in them that you can factor out. Once it's factored, then you can get the stuff like this to cancel, and you'll be left with your answer. Again, this is 2 answers. You do it once with plus, and you do it once with minus. But you can leave it written just like that. 1 plus and minus root 2 all over 3. That's what happens whenever you use the quadratic formula, and we use the quadratic formula a lot in this class. It might have been like a 3-day thing you did in algebra 2 years ago. But in here, the quadratic formula is going to come up probably at least 12 times by the end of the year. And it always has one of these kind of things in it. So let's see if you actually learned anything. Simplify that one down. Try that one. Did you use root 9 and root 2 for that root 18? That would have been smart. So then it would be 3 root 2. How many of you got 3 root 2 for that? That was a really good start. Okay. Now, what can factor out on the top? There's a 3 in both of them, isn't there? 3 comes out. What's left on the 6 there? 3 times what would make my 6? 2. Plus and minus, and the 3 comes off of the root 2, and I have root 2. If I'm not sure if I'm right, I can always multiply this back out again, and I should get what's on top. And then it's all over 3. And then the 3's canceled. Before I said it, how many of you had 2 plus and minus root 2? Good. You've learned another thing that you have to know, which is basically the simplifying of square roots, factoring, and canceling. All those are really important skills because it comes up in the quadratic formula all the time.